Welcome to the spring session, to the spring framework session at Voxxed Vienna. This is going to be a very source code centric presentation, so I'm not going to do any live demos of the kind or anything of the kind. We're going to have a look at the heart of the Spring component model, and we're going to look at it at its most up-to-date state. So take the 4.3 here as a kind of state-of-the-art as of Spring Framework 4.3. There's actually a lot of stuff that has been around for longer than that. We're not going to do a what's new in 4.3, but there are going to be quite a few Spring Framework 4.3 features shining through, and I hope I'll remember every time that I'll point out that those are specific 4.3 additions. Maybe just as a context for what we're talking about here, the Spring Framework component model has a long history, right? It dates back to 2003. Long time, really, in particular in this industry. And it has been, well, it has seen several stages of evolution. It's actually almost an ongoing process of evolving the component model. And in the 4.x series, there have been a lot of refinements. 4.1, 4.2, and 4.3 each qualify as major releases in that sense. They introduced so many programming model refinements that many other projects would have probably called them 5.0, 6.0, and 7.0 or something like that, right? But we're pretty conservative in our version numbering. In any case, we're going to take a state-of-the-art perspective. We're going to look at what Spring Framework, the Spring Framework component model has on offer right now, or actually more like as of end of May, because 4.3 is not out yet. 4.3 is going to go final, going to become generally available by the end of May this year. So we are a little bit ahead of our time here. But most of the stuff I'm covering is in 4.2 anyway, so obviously that can be used right now, right here. All right, quick background on myself. I'm serving as the Spring Framework project lead in the sense of I'm responsible for everything that lives under the Spring-Framework project on GitHub. The Spring team largely works at Pivotal. I almost prefer saying is being paid by Pivotal to work on the open source projects. I exclusively work on the Spring Framework open source projects, so I've been doing this for a long time, basically ever since its inception. So I'm doing this for 13 plus years now. In the meantime, I've seen Spring grow from 0.9 to literally 4.3 and 5.0 now. All right. So quick poll maybe. Who's been working with Spring already? Yeah, usually it makes more sense to ask the inverse question. Who hasn't been working with Spring yet much at all? Anybody? Who's on the latest? Who's working with Spring Framework 4.2? 4.1? Anybody still on the 3x line? All right. There's going to be stuff in there for each and every one of you. I hope that what we're talking about here also serves as a reason for finally upgrading to Spring Framework 4.x from if you're still on 3.x. Anyway, all right. Let's establish some common ground. I'm not going to rehash the core component model too much here, but in order to understand the design context, it's important to actually look at the heart of the model. Because what we're doing here is a design review largely. We're looking at the programming model and the configuration model from a design perspective in terms of the readability of the source code, in terms of the expressiveness of the source code. And this is a perfect example for a start. Just any Java class living in your code base, having the role of a component, in this case of a service component in your architecture, being expressed as a Java class, of course, using regular Java means, and we're going to return to that several times, the use of standard Java language features in the Spring programming model. This, of course, is just a regular Java class implementing a service interface, at least it looks like it, right? So I guess this method down here could actually have a net override on it because it probably implements that service interface. It has the update book method in there. it has a stereotype on top. It says add service, which formally declares this class as having the role of a service class. So we're not just saying so in the name, my book admin service, we formally say so through a type-safe annotation, and an annotation that can be used for tooling purposes. Basically, any tool or any runtime infrastructure can reason about those annotations, because the annotations are all preserved at runtime. So a tool can, for example, classify your code base or some views on your code base based on those stereotypes. Because service essentially is a stereotype. It is what the good old UML had in the 90s, in the late 90s. Basically just a marker on a class diagram at the time. These days, class diagrams aren't that fashionable anymore. But the same kind of concepts still apply when going through your code base, when managing your code base, when trying to understand your own code base after a year or two. So, this is an add service class. It happens to have an add lazy marker. We're going to see that later on. This is just an indication for additional characteristics expressed on the class. Notice the readability. My book admin service is a lazy service. You have to invert the order a little, but you can actually read it. My book admin service is a service. It is a lazy service. The same applies, for example, to the update book method down here. It's marked as add transactional, of course, in Spring, commonly known, right? Declarative transactions. Transaction is going to be started before we invoke the method and committed and rolled back after the end. We know that, right? Largely. So add transactional at the source code level is actually a characteristic. You're saying, you're expressing, formally expressing, that the update book method is transactional or has transactional characteristics, whatever your preferred way of reading it is, right? But it can actually be read that way. This is also the reason why many annotations in Spring actually are descriptive in their naming design. This is not transaction attribute or whatever, right? It's also not shortened too much with @tx. It says add transactional to describe the method or class that it's annotating. And at the heart of what the core container does in Spring, of course, there is dependency injection. And in our particular case here, to basically close the core arrangement, we have a constructor that's designed for dependency injection purposes. And commonly, that would be annotated with @autowired. So @autowired in Spring, typically found on constructors these days, but it can also be found even at the field level or method level. It can be setters, can actually be other methods as well. Anything that's injectable follows the rules. Something that declares parameters, like in this case a count repository. And the count repository is a dependency which this my book admin service needs in order to do its job, right? Classic dependency injection applied. So why is @autowired commented out here? That's actually already a 4.3 hint. As of 4.3, we are a little bit more lenient in what we accept without extra metadata. If traditionally you just have a class, you register it with the core container through component scanning or register calls, any standard means, right? No extra metadata externally. We insist on a non-default constructor to be marked as @autowired. Otherwise, we think we need to call the default constructor, because nobody told us which constructor to use for injection purposes when the container is creating the instance, an instance. As of 4.3, the algorithm is a little more lenient. It says if there's only one non-default constructor, and it looks like an injection constructor, right? It has resolvable arguments. We're simply going to invoke that one instead of saying, there's no default constructor. Right, so that's why it's optional. I actually recommend annotating those artifacts in any case, because it adds to the readability and the understandability of your source code. But if you've got many components, all with just one constructor, all designed for injection purposes, and maybe most of those components don't have any other Spring annotations in them, that's the main reason why we allow such constructor arrangements without an explicit annotation as well now. to not creep into classes where otherwise Spring wouldn't shine into. The annotation model in Spring is composable. So that's actually one of the most powerful stories in the entire Spring component model. Almost, I have to say almost, any annotation in Spring can be composed. Wherever you're using standard Spring annotations in your source code at the moment, you could instead use a custom annotation of your own. And that custom annotation of your own would be meta-annotated with Spring annotations. This is actually in 4.1, 4.2, it works almost anywhere. As of 4.3, it will work anywhere where it technically makes sense. Still not everywhere, but basically everywhere for practical purposes. Anyway. So, this is a custom stereotype annotation. My service above says, I'm a custom annotation, right? I'm just a source code artifact, public add interface, my service, but I'm meta-annotated in this custom code base of yours with add service. I'm changing the default scope to session. I, by default, have primary characteristics, which is one of the sweet hints in Spring's dependency injection model. It basically says, if anybody asks for a particular service interface and there's a non-unique arrangement, right? There's more than one, I always win. That's basically what that primary says. So you can bake those kinds of characteristics into a single annotation, into a single custom stereotype in this case, even a transactional annotation, right? So it's quite a few characteristics combined into one annotation. And every time you're saying, add my service in this case, in your own code base, right? That can be on hundreds of classes if necessary. Every time you're saying, add my service now, you're actually expressing the combination of characteristics above. And that's, to the day, in the entire Spring Framework 4.x arrangement, one of the most powerful design features. It's not used very aggressively in practice. I'm not seeing it much in projects, really, just very selectively. But you can take this to levels where the expressiveness of your own code base is actually a design goal in its own right? Where the language that you're using to describe your artifacts is basically composed into annotations that happen to be composed Spring annotations. So, add my service, of course, is a choice of name that you can make here, a very important part of the story. Custom annotations can have a name of their own. You choose the name. You can even design a whole language across the code base, as mentioned. So, I intentionally use dump my prefixes here so that you're not repeating it, right? So choose a better name. Call it account service, order service. Name it after a characteristic, a domain, something that matters in your architecture, that matters in your code base, that helps you to arrange your code base. Right, little variation and two further examples. It's not just about type level stereotypes. It's not just about service and component and controller annotations. It's also about any other annotation, in particular more fine-grained ones. The above one, for example, is just a scoping annotation. It says, I'm called my session scoped, right? I can be put onto a type and say add my session scoped or an add bean method. And I really only wrap add scope session. So instead of having to say add scope session with a string, you can say add my session scoped with which hard codes the scope name session. And in our particular case, it also allows for an arrangement where the so-called scoped proxy mode can be configured on a custom attribute. Let's just have one more pass in understanding what this can do for us. My session scoped has a differently named attribute. It redeclares an attribute that's actually on the add scope annotation. So it says, I don't want to name this proxy mode. I want to shorten it to mode. And I'm choosing a default of my own. I mean, in this particular case, the default is actually the same as in the add scope annotation. The important part is this default clause over there, standard Java annotation language default clause, can say scoped proxy mode target class. Your own scoping annotation can not only point to a specifically named scope, it can also pre-configure a proxy mode if you consistently intend to use this across your code base, which is generally a good idea then to create a custom annotation which basically forces everybody to use the correct defaults, the intended defaults. The @alias for annotation down there is just a way to formally describe this characteristic. There are actually ways to do this with name-based overriding, but as of Photo 2, you can point to the attribute that you intend to override, right? So the alias actually goes to scope.class and the proxy mode attribute declared on scope.class, which makes it a little easier to understand what's happening here, right? You can even click on scope.class, right? In IntelliJ IDEA, you can even click on the attribute name, and the IDE is going to take you to the original declaration of the attribute that you're pointing to there. So it's not just for the runtime arrangement, tightening it. It's also for understanding what somebody else has been doing in your codebase there, right? Maybe even yourself a year or two later. So, and just one more example to wrap this up. The transaction annotation, transactional annotation can also be customized like almost any other. This is a custom transaction annotation, meta annotated with that transactional, here numbly called my transactional. If you prefer, you could shorten it, right? You could call it @tx if you mind the characters, right, of transactional. You could shorten it to a 2-character name if you wanted to. But in particular, you can again choose which attributes to declare, which attributes to redeclare. You might know that the @transaction annotation, the standard one in Spring, has plenty of attributes. It has a propagation behavior, isolation level, a read-only flag, rollback for, no rollback for, even a timeout, right? It has plenty of customization options. What if you wanted to reduce the options? Because in your own particular project, particular code base here, it doesn't make sense for everybody to customize those. You rather want consistent behavior and a focus on just the important ones, the important characteristics. This is what a custom annotation can also do for you. Redeclaring one selected attribute, the read-only attribute in this case, which means every user of your custom transaction annotation, everybody using @myTransactional here, can only set the read-only flag. No other flag on @transactional is exposed here. And there's one more final little sweetness here. The read-only attribute does not declare a default. So instead of pre-declaring a default, it actually forces every user of @myTransactional to reason about the read-only flag and to explicitly say read-only equals true or read-only equals false. That's standard Java annotation behavior again, but can be very sweetly used here. So every user of @myTransactional, every time he or she is declaring it, needs to explicitly say true or false. They can't just forget about it. They have to explicitly wonder whether this operation is read-only in design or not, right? In order for that runtime hint to be specified and for the runtime system to make a good use of this runtime hint. All right, so much for one of my favorite areas of recent years. In Photo 3, we actually get a couple of pre-composed annotations. Composable means you can create your own, right? But in some cases, we also ship some pre-composed annotations out of the box. We do that already. Address controller is pre-composed, for example. It's a combination of controller and response body. You could create it on your own, but we ship it out of the box as of Photo 2. So those annotations are actually not rocket science. They are just pre-composed out-of-the-box annotations. @request scope, session scope, application scope do the obvious. If you look at their declaration, they just say @scope session, @scope request, @scope application, and they have a default proxy mode of target class, consistent with other such annotations in the wider Spring portfolio. @refresh scope comes from the Spring Cloud project, Spring Cloud config project. @job scope and @step scope originate in Spring Batch, and they have been around for a while. All of those are just custom scoping annotations with an @scope meta annotation. But the convenience of using them out of the box for commonly used web scopes or batch scopes down here is worth shipping pre-composed annotations. If they don't do the job for you, create your own. Those annotations do just the same thing that you could be doing in your own code base. So they can also serve as a role model, as an inspiration for what the composable annotation model can do for you. All right, let's switch to another topic worth having an up-to-date look on. Configuration classes. I guess most of you have been exposed to configuration classes before. The Spring Boot project, of course, and Spring Cloud as a consequence, makes they make heavy use of configuration classes. I mean, it's almost like configuration classes on steroids. They live and breathe every subtlety that the configuration class model has to offer. But let's focus on the basics for a moment, right? A configuration class is basically just a managed component in Spring, a regular bean, basically. It has an add configuration stereotype, so it says I'm not a service, I'm not a repository, I'm not a controller, I'm a configuration class. It has a couple of add bean methods, which are actually instance methods usually. So configuration classes have state. That might not be immediately obvious to everybody. Configuration classes are just typically singleton beans, so they have state, they can have state in fields. MyBookAdmin config here has a MyBookAdmin service method declaring an add bean. Basically, configuration classes declare further beans for the core container to expose. So the core container is going to look at all the admin methods and going to register bean definitions for them, making them available to anybody needing them for explicit access through getBean calls, or in particular, of course, through dependency injection. The method name is the default bean name. The return type is a static type hint. So the return type is actually important. Be as specific as you can with the return type of an admin method. And there can be a whole collection of admin methods here. They can also interact with each other. So if you look at the MyBookAdmin service method, it actually happens to say service set data source, and then it calls the other method. At least it looks like it, right? It calls the bookadmin data source method. The container actually intercepts that call because it needs to manage the life cycle of the bookadmin data source, right? So it's actually going to be intercepted, and if there's a singleton instance of that target data source, then that's exactly what you get, right? Right. Yeah, one more note, but we're also seeing it here anyway. The configuration class type level also typically serves as a holder for further conditions and for add enable annotations. So if you just look at the type level again, the same annotations anyway. Add profile standalone basically is a condition saying this configuration class only takes effect if the profile named standalone has been marked as active on at startup time. There are other conditions. Just look at Spring Boot. Tons of conditions, right? Conditional on bean, conditional on the presence of a bean, the non-presence of a bean, conditional on some classes being available in the class or not being available, conditional on the presence of certain types of beans, adding further beans if those other beans are already there. Spring Bean makes heavy use of the condition model, but in more traditionally structured Spring applications, probably you're only going to find that profile, which is also a condition. It's actually a composed annotation. If you look at add profile, it's declared as add conditional profile condition.class. Profile is just a convenience annotation out of the box for the profile condition implementation. Add enable annotations are equally important, even more important these days, allow for activating certain container functionality through a convenient shortcut, right? Spring largely follows a what you declare is what you get model. We are not setting up implicit thread pools. We're not even doing implicit proxying unless you ask for it. But you can ask for it at the application level. Add enable transaction management is a one-time annotation having application-wide effect. There's a convention for how it looks up the transaction manager for simple purposes just by type, right? If there's only one. And it will basically lead to interception of add transactional methods. It will lead to actual runtime transactions. If you want to get rid of runtime transactions, for example, for testing purposes, for using some of your classes in a different context where those annotations should not have that effect that you're usually having, just comment out at enable transaction management or remove it, right? It's basically an opt-in model for certain container functionality. And the entire Spring arrangement works that way. There's add enable caching, there's add enable async, there's everything that requires infrastructure to be set up, and in particular infrastructure that has side effects and performance effects. All of those are composed as add enable annotations. Previously we had those in namespaces, so the idea is not brand new, right? In traditional Spring, there was the TX namespace and the context namespace and the cache namespace. At enable, annotations are basically a Java-based variant of the same idea. Right, back to the actual point of that particular slide, right? Look at the admin declaration. It's again the myBookAdmin service method, but this time it has an argument, right? It declares an argument just like a constructor would, because basically those are factory methods, right? Admin methods are factory methods. The container is going to call them every time it needs a fresh instance. They are not lookup methods, so they're not called every time somebody asks for it. They're called every time the container decides to create a new instance. So for singleton beans, basically just once, right? The first time it's requested, if it's a lazy bean, or on startup if it's a non-lazy bean. If you want access to some other components in your factory method implementation, a nice way of doing it is put an argument there, right? The container is going to resolve that data source argument. You can add qualifiers. You get the same resolution as you would get on an auto-wired constructor. And the injection only happens when the factory method is invoked. So you can fine-tune the timing of when your components get instantiated. The data source is not requested before the bookadmin service factory method is being called. So that's been around for a while, actually. That works for years. This is new. As of 4.3, you can also do constructors on configuration classes. So just separate those things, right? A configuration class is a regular instance. It needs to be constructed. We historically insisted on default construction, basically just a non-existent, typically default constructor. As of 4.3, we allow for custom constructor arrangements. That if there's no default constructor, the same rules apply as with a regular Spring component class. The container is going to look at that method, say, there's only this one. It requires a data source. I can resolve the data source. Let's invoke it. And then you can store that instance in a field. You could also put the add auto-wired on a field, right? That actually worked before. And just use it. Just look at down here, this bookadmin data source, right? You can just refer to the field. Like in a more traditional instance arrangement in a regular component class. Because configuration classes essentially are regular component classes with factory methods. And a little bit of CGlib interception if you insist for calling other methods, but let's forget about it for the moment, right? And add auto-wired is commented out again because of the initial slide, right? Because it doesn't have to be there. It's a good idea to have it there in general, but it doesn't actually have to be there. The default behavior is also to select this constructor for auto-wiring if there's no other. Right, a couple of further Java language tricks you can do with configuration classes. By just understanding the nature of configuration classes, right? They're basically regular Java classes to the widest degree. So they can use composition, they can use, as we've seen, instance state, they can use inheritance. So what if my application config extends a myBookAdmin config, right? There's like a base class myBookAdmin config that pre-declares a method here. Maybe has a couple of abstract methods. This is not a complete class at this point, right? Maybe it has some admin methods. Some of them are declared as abstract. So a subclass can extend from the base fragment, we're calling that a configuration fragment, and substitute the abstract declarations with concrete beans. The runtime effect is the same that you would get from a regular Java class arrangement. It doesn't make a difference where those admin methods are declared, whether it's all in a single class or whether you decided to spread it out over a hierarchy. Doesn't make a difference. We're following Java language semantics. Admin methods can override the same signature in a base class, right, as usual. Abstract methods can be substituted. Admin declarations are found wherever they are in the hierarchy. So basically no surprises. Just standard Java language rules for classes applied to configuration classes, and they just work. As of 4.2, you can also do things that might not be as obvious. What if the configuration class implements a configuration interface? It implements a myBookAdmin config interface. Not a base class, right? It implements an interface, or several interfaces even. And according to Java 8 language rules, those interfaces happen to have default methods on them. Look at it from a perspective of what would you expect to happen, right? The framework doesn't actually suggest this. You declare it that way. The framework encounters it at runtime. What is the framework supposed to do with it? So this doesn't actually work out of the box because default methods are handled in a pretty special way at reflection time. So it didn't work before, but the argument was it is supposed to work, right? From a design perspective, the Java language interacting with the Spring configuration class model, this is supposed to work. We are supposed to find @bean methods, even if they are declared as default methods. They can, of course, be overridden in the concrete class hierarchy, just like any other Java class could override a default method from any other Java interface that it is implementing. So, as of for the 2, and of course then also for the 3, this is exactly what we do. We honor standard Java 8 language semantics for default methods if you happen to implement an interface where default methods exist. We find @bean declarations, we apply the same overriding rules that the Java runtime would apply to regular Java classes and interfaces. In practice, it has a sweet spot. You can only extend from one base class, but you can implement several interfaces. The interfaces cannot have state, but most configuration classes don't have state anyway. So you can compose several configuration fragments as interfaces with default methods, and then your concrete class implements the ones that it wants to combine, maybe overriding 1 or 2. It's a whole new design perspective on configuration fragment arrangements. Configuration fragments are in particular important for larger multi-module projects, where some of the modules only ship some configuration fragment, not a complete configuration. And in your concrete application project, you take those modules. They might come from other teams in your company. They might come from external projects, right? And then you just combine them and wire them internally. That's where all this configuration fragment power is really adding value. Right. A different topic again. The injection point matching algorithm. And this is actually not as trivial and obvious as you would think it is. So there is actually some news here, or recent news anyway, right? These things typically live in separate classes, right? My book-admin service down here in this example has a constructor. The constructor says, I want a my repository of account. In some other part of your system, in a configuration class, typically but not necessarily, there could be those @bean methods above. So let's just look at the my book-admin service class. The container needs to resolve this my repository of account declaration, which of course is a generic interface, needs to have a type variable, and the type variable is substituted here with an account, with the account class. The container tries to do type matching. The Spring matching algorithm, the injection point matching algorithm, is fundamentally a multi-phase algorithm, right? It tries to do a primary type match first. So it's going to find all beans implementing the my repository type, actually assignable to the my repository type, correctly speaking, right? So in our little fragment up there, it's going to find both of those my repositories. It will find 2. And in Spring Framework 3, even 3.2, this would actually lead to a non-unique bean exception. Because the container would say like, you said my repository whatever down here, you have 2 my repositories. I can't resolve that. Add a qualifier or do something about it, right? Add a primary marker to one of them or add a qualifier that matches between only one of them with your injection point. Do something, basically. Because we did not look at the generic type information. As of 4.0, and refined actually ever since, we take the full generic type declaration into account, the full expressiveness of what you declared. So if you said my repository of account, we're going to take, this could be any level deep, right? It could be a 3-level deep type variable arrangement that nobody can read. But as long as it's a valid Java type arrangement, we take it and we find beans which are generically assignable to this declaration. There's still a first pass. We're still going to find the 2 my repositories. As a next step, we're going to try to find, simply speaking, a little bit simplified, but as a next step, we're looking at the generic type structure. You said my repository of account. only one of the above is assignable to those, right? Only the account repository bean. It's actually about assignability. It's not about key equivalence. So if it says my repository account down here, there could be a my repository impl of account up there. Anything that the Java compiler would allow you to assign to a variable of your injection point type, we will also find and consider as assignable. We are following the Java compiler rules in this particular case. All right, so as of Spring 4 and higher, this works just fine. There's no need for extra metadata in order to resolve those injection points. That's the design goal behind this. No extra metadata if the type declarations are expressive enough. A very important design rule in recent years. So no qualifiers, no primary markers, just an explicit type arrangement. That's also easy to follow if you look at your source code, because it's going to be obvious to you that which one of the two is going to be picked, right? The information, to anticipate the question, the information in the generic type signatures is actually available to us, in case you're wondering. Type erasure only applies to instances, not to signatures. As long as the type information, the generic type declaration, is available in some signature, in a constructor parameter, method parameter, or field type, in a return type of an admin method, also a signature, right? As long as it's declared there, the framework can resolve it at runtime. It's a little bit complex. The reflection APIs don't really expose this very nicely, but it can be done, can be reliably done. If the type information is only in an instance, like a map, hash map, something, and your return type up there just says map, doesn't give us the key value type, it doesn't help if you instantiate your hash map with the types. We can't read that. An instance loses the generic type information. A signature preserves it. So it's either about method signatures, constructor signatures, like here, very common these days. It also works with extends and implement signatures. So if you have a class account repository impl extends my repository of account, we can also read that. So if the type information, the substitution of the type variable, happens in an extends clause or implements clause in the target class, we can also evaluate that. And it all works out of the box. We're basically trying to do our best to match it. We're going to tell you if it doesn't work. But all common arrangements just work out of the box. All right, that's the Spring Framework 4 matching algorithm, actually a complete new implementation following the same model as in the 3 generation, but basically a completely different implementation of the algorithm. This works for a while already, but not necessarily in that combination. Just look at what we declare here. The injection point says, I want a list of my repository of account. We can't resolve that because just combine features that already existed before and that we discussed before, right? The container understands collection injection for a while already. So it says, okay, you want a list, several beans matching a type. You set my repository of account. So I'm going to find all my repository of account beans for you. There are actually 2 in the system. Let's just assume this is somewhere else, right? I'm going to build a list containing both of those instances, and I'm even going to sort it for you. If there are add order values assigned to the types or to the factory methods, we're going to take those into account and going to sort them for you and inject this pre-sorted list into the constructor. It's again the same principle. You declare a signature, you declare an injection point, as we're calling it, right? The list of my repository of account. We try to do our best to match your intentions. You can, as of for the 3, also have a direct reference to a pre-declared list of account if the substitution of the element type happens in a signature, right, as discussed before. So as long as we can resolve it, because it's typically in a return type signature of an admin method, as long as we can resolve the arrangement, we can also find out that there are no account beans that we're supposed to collect into a list, that what you actually mean is a direct reference to a pre-built list of account. So as of for the 3, that's also resolvable. Don't try to be too smart in what you're trying to resolve. Don't really use type variables up there, please, right? I mean, give the most concrete type information that you could possibly give in your signatures, don't try to overload the semantics too much. Then the container does the obvious thing for you out of the box. Again, no metadata, no flag, no collection injection true or something, right? Just reasoning about the signatures, trying to do the right thing for you. Another variant, since we had lazy before quickly, what does the lazy annotation do in that sort of arrangement, right? You might wonder why there can be lazy on basically two different points, right? The declaration point and the injection point. Well, they actually do slightly different things. It's the same annotation, but it leads to a different effect. Add lazy on an add-bean method says, please, dear container, don't construct this at startup time. Just leave it at it, right? If it's a singleton bean, don't instantiate it in the pre-instantiate singletons phase. Just instantiate it the first time somebody requires access to it. That's the runtime semantics of add lazy, add a declaration point. Down here, if you basically take a constructor and injection point saying, I want the my repository of account again, but this time I'm saying I want a lazy my repository of account, this is actually a pretty sweet little thing in its own right. It declares the injection point as lazy, basically expressing that you're not going to use the given instance immediately. You're probably only going to store it or pass it on. You're not immediately invoking a method on it. Through saying add lazy, you basically allow the container to react to this hint, giving you a proxy. It's going to generate a proxy and basically interface-based proxy of my repository account. And only the first method invocation on the proxy is going to trigger the actual initialization of the target bean. This can be pretty important. The my repository bean might not be available yet, right? When you construct your service bean here. It might not be fully initializable yet. Maybe it's not even ever needed at runtime because it's a completely optional part of the system. So maybe you can even save the entire initialization of that thing if it's never used, in particular in client applications. So there are many reasons why you could want to declare this as lazy. Or maybe you want to resolve a circular reference, dare I say. Circular references are a real beast. They are a real pain. But only if both sides of the injection arrangement insist on having a fully initialized instance, right? If A wants a fully initialized instance of B and B says I need a fully initialized instance of A, in the constructor, this is not going to be cleanly resolvable. If at least one of them says, I'm okay with a lazy reference to the other bean, the problem disappears. I need to add, please don't use circular references even here. But if you run into them and you can't do anything about them because those components are not in your control, and that often happens, right? Then this might be a way out. All right. Quick side note only to move forward. You can use a different set of annotations to achieve the same purposes. Up until now, I've exclusively been showing Spring annotations out of the org Spring Framework namespaces. If you want to use standard annotations for the same purposes, you could do it like this. It's a little bit more of a, I'm not saying this is the recommended way, but it works out of the box. There's a simple add managed bean stereotype from JSR250. There's the add inject annotation, an alternative to Spring's add auto-wired. And there are a predestroyer, post-construct, a couple of other standard annotations that can be used in your component classes. No Spring imports, but the Spring container reacts to all of that metadata if it encounters it at runtime. And basically does the same thing it would do against the Spring versions of those annotations. There are a lot of things not available here. No composability of the stereotypes, no required flag on inject, no lazy annotation. But instead of lazy, there's a concept in javax.inject called provider. Provider basically is an interface with a get method. So for that reason, if you declare a provider of my repository of account, you get a generated provider basically from the framework. The provider has a get method returning their repository to you. It's the same idea, right? Like a lazy init proxy. The first time you're calling get, where you actually insist on having the object in your hands, that's when the init phase is being triggered. Before, it's basically a sort of proxy. Even that can be expressed with standard artifacts like the Java x.inject.provider interface. Right? But that's a little bit of a side note, same concepts, different metadata elements. But as a variant of it, while we're at it, right, we have support for Java util optional, actually coming from JDK 8 as well. And it's particularly nice in that combination. So what if you chose to declare a Java util optional signature? The constructor basically says, I want an optional handle for my repository of account, the Java util optional. Put yourself into the framework's perspective, right? The user said optional of something. What are we supposed to do? Well, it's obvious, right? We are supposed to create Java util optional wrappers. If the object is there, resolvable at runtime, you're going to get an optional wrapper for the actual object. If it's not resolvable, we're not going to throw an exception, like we otherwise would here. We're going to give an optional empty handle to you. You can do this with that auto-wide as well. You can say required equals false, and you get a null reference then. But this is actually syntactically nicer. You can even use the Java util optional API to react to the presence and non-presence of the target bean, right? By just being given the optional, continuing from there with the optional handle. Maybe you can even pass it on to some other API already using optional signatures. So that's another little variant of it. All of this happens out of the box. There's no extra configuration needed. If you're running on Java 8, Spring 4, for the 2, for the 3 still run on JDK 6 and 7 as well. But if you're running on 8, we're automatically registering our handlers for optional. So you just use those features in your code, in your class declarations, and the framework simply reacts to them, even to brand new features, to Java 8 features in this particular case. Very soon now, there's going to be similar support for some JDK 9 thingies. Right. Another side note, right? Basically a little bit of a bonus while we're talking about Java 8. If you use the java.timetypes in some of your classes that you're binding to, for example, in web controllers, works out of the box, just do it, right? Spring understands them. If it's running on JDK 8, there are handlers, converters, formatters available that understand the java.timetypes. The same way that we understand the jo.timetypes as well. And like before, if an annotation is commented out, even better, you can basically omit that annotation because there's even default behavior. The Java time and jo.time types are expressive enough to allow the formatting framework to have a sensible default, right? Local date is just a date representation, no time part. Local date time is a date time representation. Local time is just a time within a day. There's also support for zoned date time and co. And if the type itself is expressive enough to suggest a default representation like ISO date time, there doesn't need to be any extra metadata. No formatting annotations needed if the type itself is expressive enough, if that rings a bell, right? No extra metadata if it's not actually needed due to type expressiveness. Right, since we're talking about MVC controllers, in the remaining few minutes, I'm going to just highlight a few design ideas. I'm going to keep this short because the main point of the presentation is the core model, but some of those things actually shine through. Look at an MVC controller based on the context that we have in mind here, right? This is a Java class. It actually could have instance state. It has a controller stereotype on top. It's basically not a service. It's not a repository. It's a controller. The same model in Spring. MVC controllers are just regular Spring managed beans, basically. Like a configuration class can have add bean factory methods. A controller class running in a web context can have request mappings. Request mappings are declared on methods and suggest to the dispatcher that any incoming HTTP requests, servlet requests in particular, bindable to those mappings, right, of the same path, of the same method, with the same conditions matching, are dispatched to this particular method. So if a books new request, post request comes in, we're going to bind to the new book method. If a books one request comes in, a get, we're going to bind to the find book method. We're even going to allow for extraction of this path variable, the ID part, to extract it, pre-convert it, pass it into the method signature. These are regular Spring managed beans. They usually get dependencies through the constructor or through the fields, but any invocation time context, request specific metadata, they are typically get through method declarations on those endpoint methods. If you want access to a path variable, a request parameter, a header, a cookie, the body of the request, pre-converted, that sort of thing, you declare all of those things as a signature, as a method parameter in your method handler signatures. So the book down here would actually be pre-bound from request parameters to the fields of the book. There are default rules for all of those things. Right. A little thing to just sneak in some for the 3 stuff. Annotations can be composed, remember? So if request mappings can also be composed, there can be things like more specific mapping annotations, get mapping and post mapping, taking a path, substituting the method, being meta-annotated with @request mapping, leading to a signature like this, right? Actually, a more expressive mapping annotation as an immediate alternative to request mapping. There's no infrastructure needed for this. It just works because of composability. You could create them on your own, easily. As of folder 3, we actually consider introducing get mapping, post mapping, patch mapping, put mapping, those guys out of the box, right? So because they are actually somewhat popular, there's a little bit of a debate about it, whether it's worth it, right? Whether we should leave this as an exercise to the application developer, basically you guys composing it on your own, or whether it makes sense to ship those variants out of the box is still in debate. Folder 3 is not out yet, right? So I'm not making guarantees on whether it's in, but in any case, for the purposes of our presentation today, you can do this on your own even right now against Spring Framework Folder 2. Compose annotations like this in order to have a different reading experience when looking at your controllers. Just generally wondering, who prefers this style over that style? Who's actually a fan of the generalized request mappings here, where you can do anything and everything? I guess most of you have been using it in some form, right? Well, let me ask Team this question, right? Who would like to have this out of the box in Spring Framework? Oh, wow. I'm impressed. But again, you can do this right now. Yeah? Go home in the afternoon instead of going to a session, code them on your own on your laptop, right? And you're going to learn quite a bit about composability, actually, that way. But thanks, that's actually a good input, really good input here. All right, to wrap up the presentation. The reason why we're calling them get mapping, post mapping, and so forth is because the mapping suffix is very established in Spring. This is something you might not have used yet. It's a stomp endpoint on a WebSocket channel. This is out of the box features of Spring Framework 4.0 and higher. But let's forget about stomp, right? It's a messaging protocol on WebSocket. But let's look at the signatures of those methods. Subscribe mappings and message mappings, because in the stomp protocol, there can be regular messages and subscribe requests. So we are mapping them based on specifically named annotations binding to a stomp message path. So whatever this does at runtime, syntactically, it's very aligned with regular request mappings, get mappings, post mappings. So we have a very consistent endpoint style. And even the signatures can use the same kind of idea, requesting headers through parameter declarations and so forth. So to wrap this up, GMS endpoints available in Spring Framework 4.1 and higher are conceptually a little different what they do at runtime, but syntactically very analogous, right? GMS listener annotations on the methods, endpoint methods, they take the payload of a method through like an order parameter declaration, very similar to not only the stomp side, but even to MVC request mappings. So there's a consistency in the endpoint design. This is just an example for how far you can take the customization options. We insist on readability for the standard cases, but there are always escape hatches for customizing the configuration if you need to. This is what the example below gives you. Right, and as of folder 2, we have a similarly designed application event endpoint model. Basically, event listener methods declared through annotations. instead of having to implement the application listener interface, if you're into those things, communicating through events within a Spring application context, look at the design, right? Event listener methods, they take the payload of the event as a parameter here. Again, very similar as they can be to JMS listener endpoints or even MVC endpoints with, say, JSON payloads or those things, or Stomp endpoints on a WebSocket channel. It's always the same design mindset. And within its domain, modeling, of course, their specific domain, we're always trying to expose the power of those things, right? If you're doing Stomp, you get Stomp. We're not abstracting Stomp. If you do JMS, you get the full power of JMS, the full configurability, way beyond what you would expect. Everything that's possible against the JMS API, you get exposed here. And application events, you know that you're modeling Spring application events, local events within the application context. Semantically, we're always very close to the domain that we're modeling. But syntactically, we aim for commonality. We aim for a common style, a recognizable common Spring endpoint style. All right. So much for the actual tour that I've been taking you on. Sorry for going over time a little. The roadmap, I've mentioned it before, is we're currently at 4.2.5. We're working towards a 4.3 release candidate 1 at the end of March, or actually in the 3rd week of March, aiming for the 24th, if I remember correctly. 4.2.6 going along with that as a side note. And the 4.3 general availability date is at this point end of May. That's a hard date, so we'd rather descope it than drag it out. So 4.3 GA is going to go out at the very end of May. 4.3 is the last generation in Spring Framework 4.x. There's not going to be a 4.4. And 4.3 is designed for having what we call an extended support life. Basically the same arrangement that Spring Framework 3.2x is in now, right? Multi-year maintenance, just maintenance releases on a regular basis. So with its existing system requirements on JDK 6, 7, and 8, Servlet 2.5 and higher, we're going to support it until 2020, at least that's the current plan. So for another 4 years at the very minimum. At the same time, we are already working towards a Spring Framework 5 release for early next year, with the first milestone to appear mid this year. Spring Framework 5 is going to raise the system requirements quite a bit. It's going to be JDK 8 based out of the box, dealing with JDK 9, dealing with reactive architectures, dealing with a lot of things that are at the moment in an advanced prototype state. In any case, Spring Framework 5.0 and 4.3 are going to coexist for several years, right? So 4.3 is the last 4.x feature release, the last feature release that works on JDK 6 and 7. As of Spring Framework 5 and higher, we are going to be a little bit more radical. JDK 8 plus, Servlet 3.0 plus, and those things coming to you next year. So much for the roadmap. Thanks for your attention. If there are any questions, I'm available right now down here and all day. I'm actually flying on to another conference in the evening, but I'm here all day. So if there's anything you'd like to discuss, to better understand or to give feedback on, please just approach me. Thanks for your attention. Enjoy the rest of the conference.